Let's symbolize the process that we just went through. We've got a force, we've got mass m1, mass m2, separated by distance r. No longer 100 kilograms, 70 grams, and 3 centimeters, but just arbitrary masses that we're going to speak of in terms of symbols. Newton's formulation tells us that the force is G times m1, m2 over r squared. And we're going to go ahead and just go through the calculation of the flux once more to see what we get. So we determine that the acceleration of the mass m2 therefore has to be, okay, we're going to call it g because it's acceleration due to gravity, and it's going to be the acceleration F over m2. Okay, whatever force is exerted here acting on m2 is going to give you the acceleration of gravity, which is going to be the gravitational field strength. Well, F is gm1 m2 over r squared here, and we divide by m2. It's pretty clear that the m2's divide out. We get gm1 over r squared. So that there's an expression for the gravitational field out here, at least where m2 is. And of course that's going to be the gravitational field all the way around this sphere. Now that we know that the gravitational field strength is g m1 over r squared, gravitational field strength due to the mass m1, the area of the sphere of radius r is 4 pi r squared, and it follows that the flux, which is the gravitational field strength times the area, is just going to be given by this expression, where we have the gm1 over r squared here for g, and the area is 4 pi r squared. Well, what do we get when we multiply this out? The r squared in the denominator multiplies the r squared in the numerator, so the r squareds go away, and we end up with 4 pi gm1. That's exactly what we should get from the flux picture. The flux picture says that the gravitational flux due to the mass m1 is 4 pi gm1, because gravitational flux is 4 pi g times mass. And that's very consistent with what we have here. So we see that the flux picture does follow in a very simple way from the Newton picture, from the force picture, since Newton expressed things in terms of forces and not fluxes.